Okay, so hello everyone, very good evening all of you, very good evening guys, welcome to this session. So how are you all doing? Just let me know in the chat box everyone, how are you all doing? I'll just check it once. Perfect. So hi everyone, very good evening all of you, very good evening guys. Welcome to this live session only onto the YouTube channel Unacademy Computer Science. So how are you all doing? How is everything going at your end? How are you all doing? And even how are your preparations going on for GATE 2024? Okay, fine everyone. So I'll start on with this very quickly about letting you know about the batches which are right away going on with the off as well, which is right away, and you can just use that and get it your like 60% off to a lot of courses over the same. So I'll just brief you about the same. So starting on, you can save up to 60% off with the 6 months of free extension onto GATE and ESEs for the CS and IT subscriptions. Okay, so you can just join the Prarambh and the Vishwas batches for GATE and PSUs 2025 and 26, which is going to start on 16th of December 2022. So if you want to prepare for GATE and PSUs for either 25 or 26, right, you can just join in these batches and surely you can just start learning with the same. So as of here, we are having two different subscriptions, the Plus and the Iconic. Okay, the Plus one is of about 12 plus 6 free months, and Iconic again, it's the durations are same for both of them. What differs is the prices. Okay, there is a difference between the prices for your Plus as well as for your Iconic batches. Right, you just have to hurry, and this offer is valid only and only till 16th of December 2023. Right, so what code you can use is SHA10. Right, you can just use SHA10 for getting your maximum discount for the same. Okay, for more details about the same, you can just call on to 8585858585, and you can surely go ahead and get in all the details about the things. Right, so that is what you get over here. So as in the terms and conditions are applied, which are applicable onto the platform also. So this is applicable for 1 year and other above subscriptions also. Okay, so that is the thing. Now talking about further, as I was talking about, you can save up to 50, you can save up to 60% off. You can save to 60% off with the 6 months of free extensions onto GATE, CS and IT subscriptions. Okay, so onto that respectively, what you could do is that you can just take the Plus benefits, right? You get it in the Plus and the Iconic both. Okay, you can just get in the benefits of high quality printed notes. You get it in the, you do not get it in the Plus, but you get it in the Iconic also. Okay, one-on-one live mentorship, do not get it in the Plus, but get it in the Iconic. Okay, so just give me a minute guys, just give me a minute. Okay, just a minute. Yeah, just give me a second guys, just a minute. Yeah, fine. So as I was talking about, you can just save up to 60% off with the 6 months of free extension, right? So onto the GATE and CSIT subscriptions. So what benefits you get in up over here is you get in the Plus benefits, which is for the Plus and Iconic both. Okay, you will get in the high quality printed notes that you do not get in the Plus, but you get it in the Iconic. Okay, one-on-one live mentorship, do not get it in the Plus, but you get that in the Iconic. Okay, customized route solving, you do not get that in the plus, but you get it in the iconic. Fine, so these are all the benefits which you have over here for the plus and for the iconic also. Right, so this is going to be valid till 16th of December. Again, you can just use the code which is SHA10 for getting up all of these discounts onto your courses for the same. Okay. Moving ahead, the Prarambh batch for the GATE and PSUs 25 CS and IT, it is starting on 16th of December. Okay, it's gonna be Hindi plus English, CS and the batch A. Okay, so you'll be starting with the C programming and data structures and the computer networks. Okay, enroll now. Again, I'm saying you can use my code which is SHA10 to get a 60% off onto your courses. Right. Further, you have the Vishwas batch which is for your GATE and PSU 2026 CS and IT. It is starting on again December of 16th. Again, the language is Hindi plus English, CS, and that will be a batch A also. Fine. So you are going to start with the C programming and data structures, and again the computer networks also. So right, that is how you will be starting on with your courses for the Prarambh and the Vishwas batches. So the people who will be taking up the iconic subscriptions, those people will be provided with the books that will be delivered up to their homes over there. Right, so you'll be delivered these books within 15 days to your home. The list of books is digital logics, operating system, programming and data structures, theory of computation, computer network, database management system, compiler design, computer organization and architecture, discrete mathematics, algorithm, engineering mathematics and aptitude. Okay, this is all what you get over here in terms of the list of the books and the same. Right. So moving further, nothing can stop you from chasing your GATE, CS and IT dream. You can just get started with a no-cost EMIs and a 0% interest onto the loan for as low as rupees 3,599 per month. Okay, you get the approval in 2 hours, you get the minimal paperwork, and you get the flexible tenures also. So again, for all of these, the terms and conditions have been applied. Okay, these are available on the platform. You can just call on to 8585858585 and get all the details for the same. So right now you can just have in the All India Mock Test series for GATE 2024. So this will be on December 17th and 24, right? So you can see your branches are, and the timings are mentioned for the branches. For CSIT time is 9:30 to 12:30, EE 9:30 to 12:30, ECE 2:30 to 5:30, CE, ME and CH. For all those 2:30 to 5:30, right? These are timings which are mentioned up over here. So you can just enroll, you can just go ahead and take these exams for your complete experience for the GATE 2024. See, with these what you will get to learn that what more you have to learn, right? What you are lacking in terms of any type of questions or maybe any respective topics or something. Okay, this gives you a better idea about the same. So you can just scan also this QR code and enroll completely for free for these exams. And these are all the people who have already cracked out GATE 2023. So congratulations to everyone over here for the same. Great everyone. So okay, very good evening Harshit, very good evening Bhumika. Fine. So first of all, this was what I had in terms of delivering in terms of whatever we are offering right now. Right now, I will just come on to our today's topic, that is decision trees. Okay, we'll be learning about this very soon. Great. So before that, I just want everyone whosoever is here, just drop me a hi or drop me a yes in the chat box, guys, so that I get to know that you are over here, and further we can start in the session for today. Right, just drop me a hi or drop me a yes in the chat box, guys, if you all are here, so that we can start in for today. Okay, hey Harshit, hi, welcome to the live stream. Okay, let's start in for today, guys. Let's start in for today. So at today's topic, we'll be discussing about decision trees in detail. It will be discussing that what decision trees exactly are, what do you do exactly with the decision trees, what comes up in what kind of a data decision trees can be like applied, right? how to apply those, everything will be discussing over here in detail into this particular session of today. So let's get started with the same. Okay, so as we are only learning about the supervised learning techniques as of now, as of, from past 2 to 3 days, right? So decision tree, this is also a supervised learning technique only. Okay, so it can completely be used for the classification and regression, both of the problems for you. Okay, it can be used for either classification or regression problems for your supervised learning, right? But when we talk about that, what it is more preferable, so the more preferable is about solving up your classification problems. So if you are seeing, so when I have we learned about KNN and we learned about support vector machines also. Yeah, we learned about these two, right? So if you have seen about the same, so every of these algorithms supports your classification and regression both, right? But when it comes about what should be the preference, right? But what is the preferred one? So preference is also always given to the classification problems, right? Preference is always given to the classification problems, right? And the reason for that is that every time it is kind of a thing you mostly get the things which is preferred in terms of supervised learning techniques. It can be used for classification and regression problems, right? But mostly preferable is your classification problems over the same. So what happens under your decision trees? Okay, what happens under your decision trees? So the thing which happens that it is a tree structured classifier. Okay, just a second, guys. Right, so I was talking about what decision trees is. It is a tree structured classifier. Now what happens? Here you get the things as a tree structure. Okay, if you have gone through my DSA series where I have talked about trees with you all, right? I have talked about trees with you all in my data structure series, right? So what we did, we just made up that tree structure kind of a thing and everything over the same, right? So now the same kind of a thing is done here also. Under your decision trees, you are having a tree structured classifier, right? Where you have the internal nodes that is representing of the features of a data set. Okay, those represent of the features of a data set. Branches represent the decision rules, and each and every leaf node that represents of the outcome. Okay, that is the thing. So it is completely tree structured classifier where you have the internal nodes which is representing the feature of a data set, branches which represent the decision rules, and each leaf node that represents the outcome, right? I just slowly and gradually further only I just let you know about those things, these things in detail also, what represents what and how these can be structured also. But as of now, try to understand what are these nodes representing. Internal nodes tell you about the features of a data set, branches tell you about the decision rules, and a leaf node tells you about the outcome, right? That is what you get in up over here. So everyone, am I clear up to this particular place to all of you? Am I clear till this place to every one of you about this internal nodes and about this branches and about these leaf nodes? Am I clear till this place? Okay, Aditya. Fine. So what happens in decision tree? So into a decision tree there are total 2 nodes. Okay, a decision node and a leaf node. Okay, there are 2 nodes, decision node and a leaf node. So decision nodes, so what are they used for? They are used for making any decisions and which have the multiple branches. Okay, decision trees are completely used for making any decisions and having multiple branches also, whereas the leaf nodes are the outputs of those decisions which do not contain any further branches. So decision nodes are the ones which are helping you to make up any decision, and they even have a multiple branches. Because see, let's say I want to make up a decision of attending the class or not. Because see, this is a decision, right? Now attending class, either it can be a yes or it can be a no, right? So no, if it is no, so in that case you will be saying, okay, why? What's the reason why you are saying no? But if it is yes, we will say that okay, that is the leaf node, because that is the output, and now it doesn't has any further branches also of my complete decision node. It doesn't have any further branches. So we'll say that okay, this is a leaf node. So for whatever the decision nodes we have to make up the decisions, they are having a lot of branches, and those branches, into those branches, one branch will be the output, and that output one is known as your leaf node. Okay, so everyone, am I clear what do you meant by decision node and the leaf node? Yes, everyone, are you clear what do you mean by decision node and the leaf node? Yes, no, something. What happened to you all today, guys? Is something today? Like, because even less of you have joined in the session, and the people who have already joined are not responding. What is the reason? Do you have something today in terms of any exam or anything? Okay, okay, if it is clear, perfect. Now, what decisions are? Now, you know, we perform the test onto our columns, onto our variables, whatever we have. We try to perform the test onto that, right? So, what are these decisions? So, these decisions are completely the test which we perform onto the basis of features of the given data set. Whatever the features we have onto the data set of our data set, right? So these are what? These are the decisions of, or these are the tests which we perform onto the basis of the features or of the given data set. Okay, and that is what decision trees exactly are. Fine. So not decision trees, but we'll talk about decisions only. So these are the decisions. Okay. So even what happens, it is a graphical representation for getting all the possible solutions to a problem. Okay, decision trees are a graphical representation for getting all the possible solutions to a problem or a decision which is given on the base conditions. Absolutely right. So this is nothing but decision trees actually are a graphical manner for getting your conditions, for getting your possibility of the solutions or the solutions to a problem represented in a graphical manner, so that it becomes easy for you to go ahead and take out the respective decision for your particular problem. Okay, this is just a graphical representation, and as we all know that if we learn something through the graphical representations, so that becomes very much easier rather than just writing that down or note that down somewhere. It becomes much easier to learn anything with the graphical representations. So this is what decision trees are, right? This is even the reason that why we generally use a decision tree. Okay. So am I clear with the reason, guys, that what exactly a decision tree is and like why do we use it? Yes everyone, do let me know guys, am I clear with the same? Just help me out with the same guys. Yes, no, something. Okay. Fine. Next we are proceeding on ki it is called a decision tree. The reason is because it just looks like similar to a tree. Okay. It looks similar to a tree. So what it does, it starts with a root node. Okay. It starts on with a root node and further expands onto the further branches. Okay. And it constructs up a tree like of a structure. Okay. See, this is a diagram for your decision trees. Okay. This is a diagram for your decision node tree as I was talking about. So see, trees look like this, right? You are having a condition over here, then you're having branches for that. Maybe again the conditions are over here. Again you are having sub branches for the same, and moving on like that you are having the branches and sub branches for the same, right? So this is how a decision tree looks like. So at the very top, what we have, at the very top we have this decision node, that is also known as your root node. Okay. So our complete diagram for your decision trees starts on with a decision node. Moving further, you are having two other decision nodes. Okay. Now, for the other decision nodes, here we are having the next as a leaf nodes. As I told you, leaf nodes are the ones which are the branches of your decision node. And these are also the output for your decision nodes. Right. Further, if you won't have any branches, that will be termed as your leaf node. So, you can understand in a way that leaf node is something which is just the ending of your complete thing. Right? So, yeah, this is just a second, guys. Right, so yeah, understanding for the decision nodes, this is what like we have exactly over here, that it is a root node, right? Further proceeding, we have the further decision nodes, which is a subtree. Okay, the decision node further we are having. So for that decision nodes, you are having up the leaf nodes, which are maybe kind of a simple like just a branch of that decision node, and that is all what it is over here. Right, apart from that, you have nothing in the same. So for both the decision nodes, you are having the further leaf nodes. Okay, you are having the further leaf nodes on both of those. And further talking with the decision nodes, again you are having the further leaf nodes. So see, whatever is the leaf node, right, that will be the end of that particular tree. Okay, leaf nodes are termed as the end of your tree because leaf nodes further do not have any branches. So exactly this is how a decision tree looks like. This is the method of a decision tree, which like how exactly it looks like, right? So hope everyone is pretty clear with the same, guys. Okay, Neeraj ma'am, question किस type आएगा gate में? Okay, see Neeraj, questions can be come in from decision trees, and questions can be kind of a कि you might have been given up a tree and now you have to just based on the tree you have to go up to or maybe find up to a result that what is the final result of the complete analysis, or maybe what is it trying to represent through the graph, or what exactly they are trying to find through this graphical representation. These kind of things could be asked in the terms of this particular in the paper of gate. Otherwise, what could be done is कि you like exactly you can be given up a data, and with that data you have been asked, okay, which algorithm best suits this particular type of a data, right? So that is where even decision trees come into the role. Okay, every time you have to understand all the algorithms and better know which algorithm can be used where, so that it is betterly for you to like further go ahead and check out the same. Okay. So yeah, everyone just let me know, are you all clear with the same? Okay, fine, Neeraj. Okay, apart from Neeraj, rest everyone as well, I just want some answers from you guys. Is it clear to you all? Okay, fine. So I'll just get back over here, and yeah. Now for building up a tree, what do you use? You use of the CART algorithm, C-A-R-T. It stands for classification and regression tree algorithm. Okay, you use of the CART algorithm for building up a tree in the decision trees, classification and regression tree algorithm. Okay, that is what you get over here. CART, classification and regression tree algorithm. Okay, that is what you have up over here in terms of building the thing which you get up over for the same. So now at decision tree, simply ask your question based on the answer yes or no. Otherwise it further splits the tree into the subtrees. Yeah, absolutely right. That is only the thing which you have up over here. In the decision trees, you have the answer in terms of yes and no, right? And if there is no nothing answer for yes or no, it will further split up your decision tree into the subtrees. Okay, how it will be done, I'll just show you very quickly. A decision tree, let's say, right? This further branches of that. Now here it can as well be further divided up. It can be divided up over here also. Let's say for this you're having some other branches. So this all completely depends for yes and no, right? It completely depends on to your yes or no kind of answers, right? Whether it is like generally the solution for your problem is yes or it is no. Based over this, it was further divided and worked over the same. So that is how a decision tree is completely worked out. Decision trees take more time. Yeah, absolutely right. So when decision trees take a little bit more time as compared to the others, and yes, the reason is absolutely the same, because you have to make up a complete graphical representation gets created and then worked over the same. But this is something which will give you even the accuracy more, Suman, right? Because we always say that this is something, graphical representations are something which gives you a very accurate answers. Okay. Okay, Aditya ma'am, I have some doubt regarding ISRO ICRB exam. Okay, Aditya, you can just let me know your doubt, and in case I knew about that, I'll surely let you know. Okay, in case I know about that same, I'll let you know that thing. Now next is why to use up the decision trees. Okay, what's the reason why you should use a decision tree? Next is this particular question. So see, there are many algorithms in machine learning. We know we have been learning 3 yet, and still many more are to be onto the way, right? So best algorithm, so choosing of the best algorithm for the given data set and the problem, that is the main point to remember while creating a machine learning model. Absolutely right. As I was saying to you all from a very long time, that we have to be very clear with and very punctual with that what kind of this respective algorithm we are using, right? Whether it is suiting up my ML model or whether it is not suiting my machine learning model, or what is the reason for the same, right? This is which we have to be very clear with, right? So below you are having the two reasons for using up the decision trees. Okay, very first reason is that decision trees, they usually mimic the human thinking ability while making a decision, so it is easy to understand, right? Okay, 1 second. Neeraj, machine learning MCQ question practice kar. Yeah, Neeraj, we will be practicing up the machine learning MCQ questions also. We will be practicing. But before that, what I was thinking for you people, just at least have a little bit of info and the knowledge about ML, the things which we are having up over here, so that it becomes easy for you to then solve up the questions, right? That is the reason we are just having up the theoretical sessions a little bit, then we'll be even having the practical sessions too. Yeah, sure, Harshit, I can. So generally, for using up the tree, you use the classification and regression tree algorithm, CART algorithm. Okay. Now, further in the particular thing, this particular one, this is only the CART algorithm, how it looks like generally. Ki you have to classify, first of all, right? The very first thing goes is you have to classify the things based over whether it has to be classified or not. And even for the same only, you just like simply apply up the yes or the no answer, right? If it has to be further taken in, then you say yes, otherwise you say it is as the no, right? So yeah, that is what you have up over here in terms of giving up the answers for the CART algorithm, right? But as in very detail, we haven't discussed it yet. But this is something which like you classify up your decision based over the yes or the no, right? And further, if it is yes or either it is a no, just based on that, further it is classified for the same, right? But yeah, whenever your one of the subtree or one of your branch will be ending, that is called as your leaf node. Like whatever further you don't have the sub branches, that particular one is known as your leaf node over there. Okay. Soumya Raj, difference between DFS and BFS. I guess, Soumya Raj, you're talking about the depth first search and breadth first search, right? Is it regarding the DSA, Soumya Raj? I guess this is regarding the DSA, right? Okay, so just allow me a few minutes. Okay, just let me complete the decision tree thing. Then I'll be coming to your topic of this DSA, right? Because it is kind of a little very out of the track as of now. Okay, so just allow me a few minutes. I'll be coming to your question. Okay. Fine. So now, what are the reasons why you should use decision tree? Okay, thank you. Thanks a lot for understanding. Thanks a lot for understanding, Samiraj. See, now let's talk about that. What are the reasons for using the decision trees? Okay. So see, the very first thing is decision tree, they usually mimic the human thinking ability while making up a decision. Okay. They usually mimic the human thinking ability while making a decision, so it is easy to understand. Absolutely. See, this is one of the very important reasons that decision trees are easy to understand as compared to the other algorithms. Yes, this is true. And the reason is not because, see, graphical representations are much more easier, right? And we as well, whenever we have to like learn something or do something, we just try to think it in the graphical way, right? That if this is the thing, then this might happen, or if this is the case, then this might happen, and if this is the case, then something will not happen, and this is the respective answer. Kind of things we like think about the same, right? So yeah, this is where we say they actually like usually mimic human thinking ability while making up the decisions. And the logic behind the decision tree can be easily understood because it shows a tree-like structure, right? As I was saying about graphical representation and that tree-like structure. So, you know, in complete decision tree, there is only one thing, that is graphical data, graphical representation. That is the only thing that generally or many times we use of the decision trees. In comparison to using any algorithm, we try using up the decision tree, and this is the most important reason for the same. Okay, fine. Now here we are having up a few terminologies for your this respective decision tree. But before that, let me know, are we clear the reasons that why you should use a decision tree? Okay, Suman, I'll just give you an example. Okay, I'll give you an example. Just let me explain you about these terminologies. Then I'll take you towards the example only. Okay. Okay, Harshit, so I was talking about like whether you people are clear with why to use a decision tree, because the very first reason is they can usually mimic up the human thinking ability, right, while making up the decision. So in that case it is easy to understand. And the second is that the logic behind a decision tree, that can be easily understood because it helps you to show up a tree-like structure, right? These are the two reasons for using up your decision trees. Okay. Okay, fine. Moving towards now the terminologies. Let's have a word about the terminologies as of now. So let's understand about the root node first of all. Okay. So root node is from where a decision tree starts. The very top point of my decision tree is a root node, right? So let's say my decision tree starts from here. So this is my root node. Okay. It represents of the complete data set which further get divided into two or more homogeneous sets. Absolutely. So it is kind of the very starting of my decision tree. Okay, and with the help of root node only, my complete data set further gets divided into two or more than two sets. Okay, Somiraj, just let me complete this decision trees thing, then I'll take your doubt. Okay, just let me complete this decision trees thing, I'll take your doubt in that case. Next we have the leaf node. Right, so leaf nodes, these act as a final output node. Okay, and the tree, these cannot be segregated further after getting up a leaf node. It cannot be segregated further after getting up a leaf node. This is what leaf node. Leaf node is kind of just a final output. Okay, this is just a final output. What happens under splitting? Splitting means dividing your decision node or your root node into the subnodes based on the given conditions. Absolutely. Split means, that you all know, dividing your further branches, right? If I talk about the branch or a subtree, so that is a tree which is formed by splitting up the trees. Okay? Pruning, this is a process where you remove the unwanted branches from the tree. There might happen that you are having some unwanted branches also from your tree, into your tree. So this is something where you remove the unwanted branches from your tree. Okay, pruning is that particular thing. It is like completely helps you out for removing up the unwanted branches from your tree. Next is you are having up the parent and the child node. So that is the root nodes we have in the tree, and those are called as your parent node, right? And the other nodes are called as your child nodes. That is the thing. Okay. So whatever the root nodes are we have in the tree, that is the parent node, and the other nodes which we are having, that are called as your child nodes, and that is it. These are just the terminologies that you have to be understand while you are going through this decision trees thing, right? You have to understand about these things in a very clearer way. Fine. That is it about the same. So just confirm me, are you all clear with all of these terminologies? Clear with all these things which I have mentioned up? Okay, Harshit. What about the rest, everyone? Okay, Somiraj. And I hope you all are even making up the notes also of everything over here, right, in the details, so that nothing goes wrong for you in terms of simply not able to remember up the things, or in terms of any other kind of a cases. Fine. So first of all, you all let me know, okay, according to you, what is why do we use the decision trees according to you? Yes, everyone, let me know. What is the reason? Why do we use up the decision trees? Harshit, my question is, what is the reason? Why do you people use up the decision trees? What is the reason? Neeraj, you'll be taking the math topics also. We will take the math topics, okay? We will take the math topics, not a worry. Absolutely right. For making the predictions, right, Harshit, right? So, yeah, Somiraj, for mimic human interactions, okay. Harshit for the predictive analysis. Okay, yeah. Hey, Papa Moria. Hi, welcome to the session. Right, what are the other reasons for making decision or prediction over a given data set? Okay. Fine. So let's understand that how does our decision tree algo works. Okay, let's try to understand how does this algorithm works exactly. Fine, use democracy. Fine. Let's understand how does this work. So the very first step is you have to begin with the tree, with the root node. You have to say S that contains up the complete data set. Right. Okay. Begin up the tree with the root node, and let's say we are having S, which is having up your complete data set. Goes with the step number 2. You just have to find in what is the best attribute in the data set with the help of the attribute selection measure, ASM. Okay, ASM is actually one technique now which helps you to find in what is the best attribute into a complete data set. Okay, so here for the decision tree, you'll be using that particular one, so that you'll be dividing based over that particular only now. You'll be dividing up your subsets into the further branches, and that will completely help you to contain the possible values, whatever are the best attributes. You'll be dividing your data set, your subsets for the same. That is your step number 3, right? Next is you'll be generating a decision tree nodes which help you to contain the best attributes, right? And next you'll be recursively making up the new decision trees with the help of the subsets of the data sets, right, which are already created in the step number 3. You'll be making up the decisions and the subsets based over the same, and this process will keep on continuing till the time it is not reached up by stage where you further cannot classify up the nodes, till that particular point it will continue, and that will be known as your final node or as a leaf node. So your complete data set will be divided into further subsets till the time it hasn't reached up a particular place, it hasn't reached up a stage where it got up the respective answer. So this is what you have in terms of the decision tree working. This is how the decision tree exactly works. Okay, so clear with that, everyone? Right, absolutely right, Suman, right. Okay, Asmita, okay. So yes, everyone, are we clear? Okay, how does this actually help you to make up the decisions with the help of subsets or maybe the data sets and everything over the same? Let me know, guys, in the chat box. Are we clear with the same, everyone? Okay, Harshit. Okay, fair enough, everyone. Fine. Now, let's discuss a little bit what are the advantages of using the decision trees. Okay, simple to understand, as it completely follow up the process which is kind of a human follow while making any decisions in the real life. Okay, it is completely easy to understand. Next is, it can be useful for solving decision related problems. Okay, it can be used for solving up your decision related problems, right? It helps you to think about all the possible outcomes for a respective problem. For a particular problem, what can be the possible outcomes? It helps you to think about all of those, right? And even there is less requirement of data cleaning compared to other algorithms. Absolutely true. Even there is a requirement for the less requirement for the data cleaning as well. Fine. So these are a few advantages which you have up over here, right? So simple to understand, useful for solving decision related problems, helps you to think about all the possible outcomes, right? And less requirement of data cleaning compared to the other algorithms. That is all what are the advantages which you have for the decision trees, okay? And talking about the disadvantages, so the disadvantages are like decision tree, they contains lots of layers which makes it complex, right? It may have a overfitting issue, absolutely, which can be further solved with the help of random forest algorithm, but it has a overfitting problem, right? It exactly has a problem of your overfitting issue, right? For more class labels, the computational complexity of the decision tree might increase. Absolutely right, it might increase up for the class labels, right? Yeah, so that is what all you have up over here in terms of that is all what you have up over here in terms of the disadvantages. Many layers, so it is complex, overfitting issue, fine, and a lot of class labels, so that the computational complexity of the decision tree might increase. And increasing of the computational complexity, that's not something good, right? So see, that is what are all the disadvantages which you have up over here. Fine, everyone, these are all the disadvantages, guys, which you, this is Vakir 7K. Random forest algorithm, guys, that I'll talk to you now in further classes. Not now, I'll talk to you about the random forest algorithm. I'll talk about the random forest algorithm afterwards. Okay. So, we'll be talking about this in detail also, but not as of now. When I'll brief you about this particular random forest algorithm, then only at that particular place I'll explain you this point again. So everyone, are we clear with the advantages and disadvantages both of this decision trees algorithm? Okay. Okay, Harshit. Whatever the rest, everyone, guys, are we clear with all the things about the decision trees? Four subsets means four best attributes. Right. Completely right, Suman. Subset means the best attributes. Right. Absolutely true. Okay. Pretty clear, everyone, I guess. So how do you exactly implement up the decision trees with the help of Python programming language? Let me discuss that also. So first of all, we do the data pre-processing. Data pre-processing, I hope you all know about that same thing. Data pre-processing is something where like you first of all clean the data, you process up the data, right? You even visualize up the data, everything you do up over here. Hi Jitendra, hi, welcome to the session. So this is what you do up into the data pre-processing, right? Next is you fitting a decision tree algorithm to the training data, to the training set. So what are the training data set we are having? We will be fitting up a decision tree algorithm to that particular training data set. Okay. Next goes about predicting the test result. So yeah, whenever you have to predict up the test results also, so in that respective case, you will be further using after the fitting of the decision tree algorithm, you will be predicting up the test result for the same. Then you will be testing up the accuracy of the result. Okay. And at last, you will be visualizing up the test set result. This is a complete implementation of the decision trees. Complete implementation. Okay. So you have this respective as a pre-processing step, fitting up a decision tree algorithm to the training data set, then predicting up the test results, testing accuracy of the result. So you test the accuracy of the result with the creation of confusion matrix, true? And then about the visualizing the test set result. This is the complete process of the implementation of your decision trees. Clear with this, everyone, that how a decision tree is implemented? ओके जितेंद्र, आप सी जावा की भी क्लासेस लेते हो क्या? नो जितेंद्र, नो नॉट एग्जैक्टली, बिकॉज माय मेन फील्ड इज पाइथन एंड डेटा साइंस ओनली. सो आई डोंट टेक क्लासेस फॉर, मैं नहीं लेती हूँ जावा सी के लिए. ओके, yeah, true Harshit, true. That is what comes under the data pre-processing, data cleaning, mining, visualization and warehousing. Right, all of these things come under your data pre-processing. Fine. So see, again, the method is all same. The method is all same for applying everything onto there. Right, method is all same. Nothing is different. For every algorithm you have to process the data, apply that algorithm, predict the test result, test the accuracy and visualize the test. So that is completely same for all of the other things, right? Nothing as of now we are having very different over here. But yeah, I just want to let you know the Python implementation as well, that how is that really implemented in terms of practical thing. So yeah, this is how it is completely implemented. Okay, so yeah, just confirm me everyone, clear with the same, guys? Tell me clear with the same, everyone. Okay, Harshit. Okay, Suman. Okay, what about the rest, everyone? What are you all doing today? Okay, so till now we have learned about your supervised learning. We learned about your regression and classification. We learned about your linear regression, logistic regressions. Further, we learned about your naive-based classifiers. We learned about KNN. We learned about support vector machines. Today, we learned about your decision trees. Right? So, I hope this is what all we have learned up till now in terms of machine learning. Right? So, I would just want to ask you people a few questions. Okay, now I'll be just asking you a few questions. So, okay. Tell me, in the KNN, in the K nearest neighbor algorithm, how do you find the value of K? My question to you all is, into your KNN, K nearest neighbor algorithm, how do you find the value of K? Jitendra, I am not very sure with that case. I really don't know about this. You can just check on the channel once, Jitendra. Okay, if Vishwas would have taken, he would have like mentioned up that into the playlist role. Okay, just visit the playlist, and in the playlist will be find some or the other person taking the Java and the C classes. Just visit the playlist once. Tell me the answer for my question, everyone. For the KNN, for the K nearest neighbors algorithm, how do you find the value of K? Tell me, for the KNN, K nearest neighbors algorithm, how do people find the value of K? Harshit, and you can check higher value or by applying in the model. Okay, Harshit, I guess your previous message didn't came, and I guess you were trying to say that we take the value 5 as a default value for the K nearest neighbors, the K of that, and we can even sometimes try checking the higher values, but having of the lower value than like 1 or 2, this is something which might create our data noisy, and it might create a problem for our data. Right, so I hope you are trying to say this particular thing, right? Absolutely. So you check in the value for the K with the help of that respective thing, which is like for the K you just get the value as 5. By default value for the K is 5, and further with that you go ahead and check out the respective things. Right, absolutely true. Okay, okay, that is pretty okay. And okay, next is I want to let's say my question is that I am having two different categories with me. Alright, and now without finding the Euclidean distance and the things, I want to put up a particular number that I have to tell that this number will be in my category A or category B. Okay, let's say my category A is consisting of dogs and category B is consisting of cats. Now again I have a kind of a one more animal which is having a few of a features kind of a cat, a few features kind of a dog, right? Now I have to test and I have to like get in the result that will it be in the category A or will in the category B. So I don't want to use a Euclidean distance wala thing. right? So except Euclidean distance wala thing, which algorithm I can use for deciding that whether that particular animal should be in the category A or should be in the category B? Help me with the answer of this particular thing. Okay, you can use SVM. Okay. Okay, Jitendra. Okay, most welcome for the same. Whatever the rest, one person is saying that you can use SVM. Apart from this also, do you people have any idea? Square root, so man, you can just do the square root of samples. Okay. Okay, so you can use the support vector machine, absolutely right, Harshit. So support vector machine is actually the algorithm now which you can surely use in terms whenever you are having something in terms of where you go ahead and you don't want to use a Euclidean distance wala thing, but except that also you do with a lot of things over the same, right? So there you use of the Euclidean distance. You don't use the Euclidean distance, so for that you can use the support vector machine. That's absolutely a very good example for the same, right? So SVMs are the things which you can surely go ahead with and work for the same, right? Okay, fine everyone. So let me know guys, do you people have any questions to ask me out? Do you people have any questions in terms that you want to ask me out? And I hope you all know that every day I come live at 7 p.m. onto this YouTube channel, Unacademy Computer Science only. And the classes, I guess, have already been scheduled for tomorrow also. For 13th also you have the classes scheduled. So I request everyone guys ki do click on that notify button so that once I start the class you get notified and do not miss up the class over here, right? So let me know everyone, if you people have any questions then let me know, otherwise we will be ending the session for today. If you people have any questions guys, do let me know, otherwise we will be ending up the class for today. Okay, fine. So in that case, if people do not have any questions, so thank you everyone for attending at this particular class today. Thank you everyone for being here. I'll see you all tomorrow, same time, 7 p.m. in the evening with the next algorithms. Okay, we will be learning a lot more things for the further machine learning algorithms. So till the time, thank you everyone. Have a great day ahead everyone. Have a great evening and do share this live stream with your friends. Okay, so that if they want to join in, they can also join in and come over here, clear their doubts, learn a lot of things for the same. Either it is about your ML interviews or it is about your GATE DSAI 2024. Everything they'll be getting to learn over here. Okay. Harshit ma'am, will the whole syllabus get covered as we have See, Harshit, from my side, I'll just try to cover up the complete syllabus. Okay, from my side, I'll just try to complete up the complete the whole syllabus for your GATE, DS and AI also. Right. I understand that, Harshit, and I'm just trying to do so as well. So let's see if we can. I just hope we'll be able to complete up everything till the end of your 2 months and the starting of your GATE, this particular GATE exams. Okay. Okay, so as of not today, but yeah, further in the classes we'll be having 2 to 3 hours of classes. Also, we'll be going through a complete thing. So we will take the classes further in long also. Okay. Okay, so in that case, thank you everyone for joining the session. Thank you for being here. I'll see you all tomorrow, same time, 7 p.m. Till the time, thank you everyone. Take care and have a great evening ahead of you. Bye bye and take care, guys.